Hello students, today we will learn different psychometric processes. The different psychometric processes are sensible heating, sensible cooling, dehumidification, humidification, adiabatic cooling, adiabatic mixing. And in the adiabatic mixing we will see the mixing of moist air and water vapor. First one is psychometric processes or air conditioning processes, in which we will study sensible heating. So as far as the definition of sensible heating is concerned, it is the heating of moist air without changing the specific humidity of the air. That is, it is the addition of heat to moist air without the addition of moisture. It follows a constant humidity ratio line on the psychometric chart. Let us consider a heating box or a heating space in which it is a heating coil is given with the red color. You are seeing the Q amount of heat is being added in this heating space. So from one side of this heating space, air is going inside, and from the other side, air is coming outside. So at point number 1, the temperature of air is T1 and the enthalpy is H1, and at point number 2, the temperature of air is T2 and enthalpy is H2. So obviously it is a heating process. So temperature 2 will be higher than temperature T1, and enthalpy will be also greater than H1, that is H2 will be greater than H1. Mass will remain constant because from the continuity equation or conservation of mass, the mass going inside will be equal to mass coming outside. So at the psychometric chart we will see how this is being represented. We can see at point number 1 diurnal temperature is T1, and at point number 2 diurnal temperature is T2, and it is completely a straight line parallel to x-axis, and we can see W1 is equal to W2. So at the y-axis it is the humidity ratio. So we can see here the humidity ratio is not being changed, it remains constant. uh, Corresponding to point 1 enthalpy is H1, and corresponding to point 2 enthalpy is H2. So obviously enthalpy is going to be changed. So if we suppose to calculate the heat added to the air, we can see here if we are required to calculate heat added to the moist air. So by using this formula Q is equal to m dot Cp delta T, we can calculate the heat added to the air. So m dot is nothing but it is the mass of air being supplied, the rate of air, that is the rate of the mass of air being supplied to this heating space. Cp is humid specific heat. It is not a specific heat of air, it is the humid specific heat. So we should remember the value of Cp, that is 1.022. So it is CPM. In some of the books it is humid specific heat is represented by and yet denoted by CPM. Again delta T, it is the delta T, it is the drivable temperature difference. So that is T2 minus T1. So by using this formula we can calculate heat added to the air. So this is the schematic illustration of sensible heating of moist air. Next we will see sensible cooling. Sensible cooling is just a reverse of sensible heating. The definition of sensible cooling says it is the removal of heat from moist air without the removal of moisture. The specific humidity in this case also is going to be remain constant. It also follows a constant specific humidity on the psychometric chart. So this is cooling coil given by the red line. Uh, the reverse arrow is being shown. It shows the heat is taken out. Again, the mass of m denotes the mass of air going inside this cooling chamber, and this m denotes the mass of air coming out from this cooling chamber. T1 and H1 is the diurnal temperature and enthalpy of uh, um, inlet air respectively. And similarly T2 and S2 is the enthalpy arrival temperature and enthalpy of outlet air respectively. On the psychrometric chart it will be denoted by this. You can see uh, from this middle point the cooling process is being shown in this direction, in negative x direction, and in positive x direction heating is being shown. Next is cooling and dehumidifying and cooling and dehumidification. So in this process cooling is also done and dehumidification is also done. Both processes are being done simultaneously. And again you can see that at inlet condition T1 is given, H1 is given, and outlet condition this T2, that is the arrival temperature, and S2, that is the enthalpy, is given. Heat is being taken out from this because this is the cooling process, and moisture is being added, MW, that is the mass of water or mass of moisture, and the SW is the enthalpy of moisture. We will see this process at this psychrometric chart. This is cooling and dehumidification process. You can see point number 1 is can be denoted at this point. So in the cooling process dival temperature being decreased, and since it is dehumidification process is also taking place, so when the moisture will start condensing, we know that when it attains the dew point temperature, so dew point temperature is denoted at this saturation curve. So at this saturation curve moisture starts condensing, we can say vapor start condensing at this point, and this is dehumidification process is like this. So we can see at this point W1 may be there, at this point W2 may be there. W minus W2 will give you the amount of condensation. Next, dehumidification by cooling. Again the same process is being shown in more elaborate manner. So this one is your ideal process, ideal cooling process from 1 to 2, from 1 to 2, because from this point condensation will start, because when the moist air after cooling, when it attains the dew point temperature, or we can say ADP, adiabatic apparatus dew point temperature, then the water vapor will start condensing and it will come at this point. But actually the real process path will take this route. Your real process path will take this route, and this is 1 to 2I. This is ideal process. Next one is heating and humidification. In this process, along with heating process, water vapor is also, or moisture is also added to the air. So similar diagram is given again. MW, that is the mass of water vapor, is being added, or mass of moisture is added, and the SW is the enthalpy of that water vapor associated. Next is simply humidification. It is the addition of moisture to moist air without the addition of it. In the humidification process, it is simply addition of moisture to the moist air without addition of it. In this case, no cooling is done. In this case, no heating is being done. So it is simply humidification process. Now, removing sensible heat and moisture. At this diagram, all the process is being given. This is your psychrometric chart. We can see in the positive x direction this arrow is denoting heating process. In the negative x direction, it is showing the cooling process. In the positive y direction, this process is showing humidification process, and in the negative y direction, it is showing dehumidification process. Next, we will see adiabatic or evaporative cooling. Adiabatic or evaporative cooling. A psychrometric process which involves the cooling without heat loss or gain. That is, adiabatic or evaporative cooling is defined as it is the psychrometric process in which involves the cooling without heat loss or gain. Sensible heat lost by air is converted to latent heat in the added water vapor. This will be clearly understood by this simple psychrometric chart. This is saturation curve, and that the y-axis absolute humidity is given. At x-axis table temperature is given. So in the evaporative cooling, we can see the arrow will be shown in this direction. Since it is the cooling process, so at this point your table temperature is T1, and at this point your table temperature is T2. So in the negative x direction, cooling process is done. Similarly, if we match the line with the absolute humidity line, you can see W1 is here and W2 is here. So W2 minus W1 will give the amount of humidity or amount of moisture added to the moist air. So this is humidification by evaporative cooling. Next one is adiabatic mixing of moist air and stream. A psychrometric process that involves no net heat loss or gain during the mixing of two air streams. That is adiabatic mixing of moist air or stream. In this process, no heat is gained and no heat is lost. In this case, two air stream is being mixed. Two air stream of different temperature is being mixed. This will be shown on this psychrometric chart. From this diagram, you can see that at point number 1, air with temperature T1 and enthalpy H1, humidity W1 is coming inside. At point number 2, again the air with temperature T2, enthalpy H2 and specific humidity W2 is coming inside, and at this point both the air is being mixed, and at point number 3 the mixed air is coming out. So obviously the mass will be at point number 3 mass will be M1 plus M2. Also humidity will be changed, enthalpy will be changed. So in this case we can see that at point number 1 this condition is given: humidity W1, drivable temperature T1. At point number 2, humidity W2, enthalpy H2 and drivable temperature T2. Both are being mixed. So obviously the air stream which have higher temperature will cool down after mixing, and the air stream which have lower temperature will gain the heat and it will be heated up which have lower temperature. So finally what we will get? We will get the air stream which have intermediate temperature and intermediate humidity at point number 3. So in this way it will give you the adiabatic mixing of two air stream. So in this video, thus we have learned the different psychrometric processes, that is heating, cooling, heating with humidification, cooling with dehumidification, and adiabatic mixing of two air stream. Thanks for watching. That's all for today.